Hi everyone, good morning. Welcome to my channel Belagali's classes, Belagali's class. Yes, my friends, I was doing with successive differentiation. Successive differentiation. In that, my friends, we have 5-mark questions, one example. 5-mark question, one example. Yes, my friends, I have done a series of examples given the definition of what? Successive differentiation. And you know the fact, if you differentiate first derivative, you get what? Second derivative. So, if you differentiate first derivative with respect to x, you get what? Second derivative. It's the symbol to denote what? Second derivative. d2y by dx2. Even I told what? d by dx of this is y1, then what is this? Second derivative is y2. Second derivative is y2. My friends, I have done a series of examples based on what? Successive differentiation. Successive differentiation. Even my friends, if you see the notes, I have done with type-wise, remembering you the things which we needed, results we needed, reminded and done those examples, my friends. And parallel examples given as DIY, do it yourself, means homework examples. You must try. They are also what, my friends, equally important example. For example, I have done one example connected with what? Last example. If y equal to e to the power a cos inverse x, then prove. Then what is the parallel example? Instead of power a cos inverse x, it is a sin inverse x. What is the difference? In case of derivative of cos inverse, it is minus 1 upon root. In case of sin inverse, it is plus 1 upon root. Anyway, we are squaring both sides. Automatically both becomes plus. Like that, even sin inverse x whole square. Parallel given cos inverse x whole square. All those such examples, my friends, you must work them. They are also equally important examples. You must work them. Then, as a last part of this successive differentiation, I want to consider one or two examples on parametric functions. Yes, my friends. Yes, my friends. Okay. Already this example I have done in case of what? dy by dx. Only thing is to find second derivative. Anyway, I am repeating this once again because it is a lengthy example. Needs what? Once again, its explanation. I explain once again everything. Then we go for what? Second derivative. Yes, my friends. What is the example? If x equal to a into cos t plus log tan t by 2 and y equal to a sin t, sometimes they ask what? Only find d2y by dx2. Sometimes they ask what? Prove d2y by dx2 equal to sec to the power 4t into sin t upon a. Sometimes it's a particular case, or find the values of dy by dx and d2y by dx2 at t equal to pi by 4. Not both. They may ask this, otherwise find only d2y by dx2, or find the values of what? dy by dx and d2y by dx2 at t equal to pi by 4 or at t equal to 45 degrees, my friends. Yes. Have concentration and listen and see. Given x equal to this, differentiate with respect to t, a into constant coefficient, derivative of cos, c has a negative sign, minus sin t, log f, 1 by f into derivative of tan, sec square t by 2. What is your observation, my friends? This is not t, other than t means so to write it's a derivative. What is the derivative of t by 2? 1 by 2, 5, kx is k, 1 by 2 into t is 1 by 2. Rest is your simplification, my friends. Minus sine t. This 1 by 2 I have written here. Tan lifting to the numerator. What is 1 by tan? Cot. What is cot? Cos by sine. Sec square. Push it down. Cos square. 1 cos cancels, my friends. You are left with 1 is numerator 1 upon 2 into sine t by 2 into cos t by 2. Yes, my friend. What is this? It is 2 sine A cos A. What is 2 sine A cos A? Sine 2A. Sine 2A. Sine 2A means it is 2 into 1 by 2. 2 into 1 by 2 is what? T itself. Or 2 into t by 2. What is t by 2? Is t. Yes, sine t. Cross multiplication. Minus sine square plus 1 upon LCM. It is 1 minus sine square identity. What is 1 minus sine square? Is cos square. A into cos square upon sine t. What is it? Your LHS is dx by dt. My friends, this is dx by dt. For your information, sometimes the examiner wanted this itself, the friend may ask under what? 2 mark question, giving what? If y equal to log tan x by 2, then prove this. They may ask dy by dx is this. Yes, my friend, it is dx by dt. Y is a sine t derivative. A into derivative of sine is cos t. My friends here. Yes. dy by dx, parametric rule. dy by dt upon dx by dt. What is dy by dt? A cos t. dx by dt. It is dx by dt. Denominator reciprocal. It is sin t upon a cos square t. Sin t upon a cos square t. A cancels. 1 cos cancels. You are left in the numerator sin, in the denominator cos. You know it, sin by cos is tan t. What is this? Tan t is nothing but dy by dx. You wanted what? Second derivative, my friend. Yes, see. Therefore, dy by dx is tan t. Differentiate with respect to x. My friends, better if you write it. It is a supportive step. It is d by dx of dy by dx. It is d by dx of RHS is what? Tan t. You know this. Derivative of first derivative, second derivative. What is this? It is not a function of x. It is what? It is a function of t. Implicit in such cases. First to differentiate tan t with respect to t. It is derivative of tan is x square t. Then t with respect to x. By my friend. It is not x other than x. You are differentiating this with respect to x. When it is other than x, you have to write its derivative. What is it? Derivative of t with respect to x is dt by dx. If it is x and the derivative of x is 1, we are not writing. If it is other than x, write its derivative. Yes, my friend. What is this? Sec square t. You know the value of what? dt by dx. dt by dx. What is it? It is dx by dt. What is dt by dx? Reciprocal of this. What is reciprocal? Sin t upon a cos square t. Sin t upon a cos square t. Simplify this, my friends. Simplify this. Now this is 1 by a. Lift this to the numerator. What is 1 by cos square is sec square into sin t. So this is a. Denominator is a. Sec square with sec square is x to the power 4 into sin t upon a. What is this, my friend? Second derivative. This part is completed. This part is completed. Then you wanted what? Find dy by dx and dy by dx too at t equal to pi by 4. Then you have to put t equal to pi by 4. Tell. What is dy by dx? Tan 45. What is tan 45? 1. What is this? Second derivative. You are putting t equal to 45. Sec 45 is root 2 to the power 4. What is sin 45? 1 by root 2. Denominator is it. Simplify. Yes, my friends. I give 1 minute just to go through all the steps. 1 minute. Yes, friends. First, dy by dx at t equal to pi by 4. Put t equal to pi by 4 in dy by dx and dy by dx too. Therefore, it is what? Dy by dx at t equal to pi by 4. Yes, my friend, it is tan pi by 4. Pi. What is dy by dx is here. Dy by dx is tan t. Put t equal to pi by 4. What is the value of tan 45 is 1. Tan 45 is 1. Then you are putting in here. Yes. d2i by second d2i by dx2 at t equal to pi by 4 is it is 1 by a is there, my friend. 1 by a is there. Put here. It is set to the power 4 pi by 4 into sine to the power sine pi by 4. Yes, my friend. It is 1 by a. Tell. What is sec 45? Root 2 to the power 4. What is sine 45? 1 by root 2. 1 by root. Simplified. 1 by root 2 cancels. It is 1 by a into root 2 to the power 3, my friends. 3. So what is this? It is 1 by a into root 2 the whole square is 2 into root 2. 3 is there. Root 2 to the whole square is 2 root 2. Therefore, what is d2i by dx where t equal to pi by 4 is 2 root 2 upon a. It is 2 root 2 upon a, my friends. 2 root 2 upon a. What is it? Second derivative. So, they may ask this otherwise. They may ask what? Find dy by dx and d2 by dx2 at the value t equal to pi by 4. T equal to pi by 4. Hope, my friends, it is clear. Good example. Then on parametric, I have done dy by dx. Only the second derivative we have to do. Just that part, one example. Anyway, first part is done. Refer the first part. Then I show only the second part means d2i by dx. Then another example, good example is if x equal to a into cos theta plus theta sin theta, and this is sin theta minus theta cos theta, then find d2i by dx2. Then find d2i by dx2. Then find d2i by dx2. d2i by dx2. It is also a 5-mark question. It is slightly simpler to the what? The first example. Yes, my friend. You know everything. Dx by d theta, I hope. Minus sin theta cancels with plus sin theta. You are left with a theta, derivative of sin theta is cos theta. Similarly, you know dy by d theta, it is a into derivative of sin cancels with minus sin. Cos cancels with here. What is derivative of cos? Minus of minus. It cancels. You are left with a into theta sin theta. This is dy by d theta. Dy by d theta. Everything is done. Just refer the notes. Then what is dy by dx? Dy by dx is dy by d theta. A theta sin theta upon a theta cos theta. My friends, it is what? Tan theta. Therefore, dy by dx is tan theta. Dy by dx is tan theta. Differentiate with respect to x. Yes, right. It is supportive step. D by dx of dy by dx equal to d by dx of tan theta. This is second derivative equal to first with respect to theta into d theta by dx. Substitute the values sec squared. What is d theta by dx? Reciprocal of this, it is 1 upon a theta. A theta into cos theta, which becomes, it is sec cube theta. 1 by cos sec with sec square, sec cube upon a theta. My friends, this is the second derivative. Sometimes the friend may give at theta equal to pi by 4. Put theta equal to pi by 4 in both first and second derivative. Therefore, dy by dx at theta equal to pi by 4. Dy by dx is tan theta. It is tan pi by 4. Tan 45 is 1. Second, d2i by dx2 at theta equal to pi by 4. Yes, friend. What is this? Sec cube 45. Denominator a into theta is pi by 4. Yes, my friend. This will jump to the numerator. 4 upon a pi. It is root 2 to the power 3. Further simplifying, it is 4 upon a pi. What is this? Square into root 2. Further simplifying, my friend, any cancellation? No. 8 root 2 upon a pi. 8 root 2 upon a pi. Even, my friends, they may give find dy by dx and d2i by dx2 at theta equal to pi by 4. Even otherwise, show that d2i by dx2 at theta equal to pi by 4 equal to 8 root 2 upon a pi. 8 root 2 upon a pi. In all these, when it all depends upon what friends, examiners, they may ask in this way, that way. That spin of the question, depends on the examiners. This is second. If you wanted one small, sometimes the examiner will give one very small question. It is, if x equal to, this is y, my friends. This is y, not x. It is above is x, down is y. Yes. Yes, my friend. Another is the first one. If x equal to 80 and y equal to a by t, find d2i by dx2. Sometimes, my friends, even they may ask what such simple examples instead of this very lengthy examples. Examiners are there. Yes, my friend, it is also done. Dx by dt. A into derivative of t is 1. Dy by dt. I take support here. It is d by dt of 1 by t. Yes, friend. A into. It is minus 1 by t square. You know which formula is applied. Then dy by dx equal to, my friends, it is dy by dt upon dx by dt. Yes, substitute. Dy by dt is this, my friend. It is minus a by t square. Reciprocal of this, down is a, reciprocal. Cancellation, my friend, it is minus 1 by t square. Minus 1 by t square. Yes. You wanted to find its second derivative. You wanted to find its second derivative. Yes, friend. Now, dy by dx is, dy by dx is minus 1 by t square. Differentiate once again with respect to x. It is d by dx of what? First derivative. This is minus d by dx of 1 by t square. Second derivative, my friends, explained. Symbol minus, you know it. Sign change. Minus n upon t to the power n plus 1. What is it? It is minus of minus t cube. My friends, it is second derivative. Like this, my friends, they may go for what? Even examples on second derivatives on parametric functions. I have done 3 sample examples. Almost all varieties of the examples in case of what? Successive differentiation. Done. My friends, prepare nicely. One example under 5 mark you get. Easy part, section. Don't neglect. Prepare nicely. Yes, my friends. With this, I can say that finishes parametric differentiation. Then, based on this itself, I do another 2 or 3 examples. They will also come under what? 2 mark question under the head of what? Title. Differentiation of one function with respect to another function. Then I do some 1, 2 or 3 examples on this. Yes, my friends, this is differentiation of one function or derivative of one function. Derivative of one function. My way of writing the function with respect to another function means second function. With respect to another function. Yes, my friends, you may get what? One example under 2 mark question. This is one function with respect to another function. Yes, friend, you take 2 functions. 2 functions. Let u equal to one function of x and phi equal to another function gx. Let u equal to this and v equal to this are functions of x. Are 2 functions of x. Yes, my friends, you wanted what? Then to find the derivative of u with respect to phi. Then to find the derivative of u with respect to phi, First you have to differentiate both u and v with respect to x. First one. Then first differentiate u and v with respect to x. Finding to find du by dx and dv by dx. Yes, my friend. Why you have to differentiate? You have to differentiate both u and v with respect to x to find du by dx and dv by dx. Yes, my friend. After finding, use this formula. Use the formula. Derivative of u with respect to v. Derivative of one function with respect to another function. Use this formula. It is du by dx upon dv by dx. My friend, use this formula. Use this formula. Yes, I will explain once again. Let u equal to fx and v equal to fx gx are two functions of x. Then, my friends, to differentiate u with respect to v, first you have to differentiate what? Both u and v with respect to x, the functions of x, to find these two. After finding these two, use the formula. What is it? Du by dv equal to du by dx upon dv by dx. My friends, one example. Yes. One example. Differentiate sine square x with respect to e to the power cos x. It is a 2-mark question, my friends. 2 mark. Let u equal to sine square x and v equal to e to the power cos x. Differentiate both u and v with respect to x. Both v with respect to x. Yes, du by dx. I take the supportive step. Sine square x with respect to x. Almost you are perfect now. Power 2. 1 power less. Sin x to the power 1 less means sin x. Into derivative of sin x is cos x. Yes, it is 2 sin x cos x. Keep it as it is, we will see. Next is dv by dx. My friends, e to the power f as it is. Look at the power. Is it x? No. If it is other than x, write its derivative. So, the derivative of cos x is minus sin x. Then use this formula. Du by dv equal to du by dx upon dv by dx for the values. What is du by dx? It is 2 sin x cos x. Denominator, it is minus e to the power cos x into, you have sin x, my friend. Then what cancelled? Sin is cancelled. Minus, plus upon minus is minus. This 2 is there. To get a smart answer, lift this to the numerator. Plus becomes minus. Write the remaining. What is the remaining? Cos x. Otherwise, you write it is minus 2 cos x into e to the power minus cos x. Lifting this to the numerator. This is what, my friend, the answer for this. Once again, first function, second function, differentiate both with respect to x. Yes, derivative. Yes, derivative. Formula, use me. Yes, substitute, simplify. Yes, my friends. Now, if you want, I do one more. Differentiate differentiate yes my friend, it is e to the power 2x with respect to log x. Very simple examples. It is a 2-mark question. 2-mark question, right? Yes, friend. Let u equal to e to the power 2x, phi equal to log x. Differentiate both u and v with respect to x. Yes, du by dx. It is e to the power 2x. Yes, friend. E to the f as it is into other than x, right? It's a derivative. Derivative of log x. It is a derivative of log x with respect to x. Yes, my friend. Log x is 1 by x. Yes, du by dx, dv by dx. Use this formula now. Use this formula. Put the value of du by dx, 2 into e to the power 2x. What is it? It is 1 by x. Triple jump, it will jump to the numerator. E to the power 2x is the answer. Simple examples, my friends. If you wanted one more, yes, you copy it. Yes, friends, one more sample. Yes. This is example 3. Yes, friends. Next is differentiate sine inverse 2x upon 1 plus x squared with respect to tan inverse 2x upon 1 minus x squared. 2x upon 1 minus x square. Yeah, all these are usual, man. We have done examples on what? Derivatives of inverse trigonometric functions. We have done many examples of this. Same method. Let u equal to sine inverse x. Sine inverse 2x upon 1 plus x square. And phi equal to tan inverse. It is 2x upon 1 minus x square. Again, my friends, this example they give either 2 or 3 mark, not more than 2 or 3. No. When it is given under 2-mark question, then you can make use what? Directly we have proved their values in case of inverse trigonometric functions as what? Prove that 2 tan inverse x equal to sine inverse 2x upon 1 plus x square. Cos inverse 1 minus x square upon 1 plus x square. Tan inverse 2x upon 1 minus x square. Again, all these three in terms of what? Cosec inverse, cot inverse, sec inverse. All 6, my friends. Here you can make use it 5. It comes under 2-mark question. Maximum 3. Even if it comes under 3, use directly the formula. Then we know what is this. It is 2 tan inverse x. We know what is this. It is also 2 tan inverse x. Then you know what is du by dv. This cancels with that, means 1 itself. Yes, my friend. Du by dx. 2 into derivative of tan inverse is 1 upon 1 plus xy. It is dv by dx. What is it? 2 into 1 upon 1 plus x square pi. Derivative of tan inverse x. Derivative of tan inverse x. Substitute here. Substitute du by dx. What is it? 2 upon 1 plus x square. Division. Again 2 upon 1 plus x square. Cancellation. What is the answer? 1, my friends. 1, my friends. So like this, even selecting some examples from what? From what? Especially inverse trigonometric functions. The friend may give examples under derivatives of one function with respect to another function. If you wanted a sample, I write 1 or 2, you can practice at home. Practice at home. Yes, friends. Yes. Differentiate tan inverse square root 1 plus x square minus 1 upon x with respect to tan inverse x. With respect to tan inverse x. They may give this. You know this. What is this? We have done this as half tan inverse x. Derivative of half tan inverse x with respect to tan inverse x. Answer, you get it as what? Half. Yes, my friend. If you want one more. Yes. Differentiate. Differentiate sec inverse 1 plus x square upon 1 minus x square with respect to yes, friend, cosec inverse 1 plus x square upon 2x. Like this, they may construct examples, and even some simple examples, my friends, you can get, you can enjoy such examples. Yes, my friends, these are some examples under what? Derivatives of one function with respect to another function. Here also you have to convert in terms of cos inverse to tan inverse, sin inverse to tan inverse. Direct answer. Yes, my friends. Yes. This finishes what? Some examples on derivatives of one function with respect to another function. This finishes, my friends, entire differentiation. Yes, my friends. I take the last minute to just remind what we have done in this case. Yes, my friends. In this, I started with what? Limits continuity. We have done some examples on continuity. Find the value of k if the given function is continuous. Those examples are important under 4 mark questions, my friends. Even sometimes they may give what? Discuss the continuity or examine the continuity of the function. I have done some examples. Even one good example, that is y equal to mod x minus 1 plus mod x minus 2. Even x into sine 1 by x. Even otherwise this 3 man fx equal to defined when x is less than 1, when x is greater than 1, when x lies between this and this. So many examples, my friends, I have done. Even find the points of discontinuity. Everything is same. Yes, my friends, that comes under discontinuity. Then I given the definition of what? Derivative of a function at a point. What is it? dy by dx equal to f of at a point means what it is? X plus x naught minus fx naught upon that definition is given. Then we have done some examples. Fx minus fx naught upon x minus x naught as limit x tends to x naught. What is it? It is the derivative of a function at a point x equal to x naught. Then we have done one theorem property. Every differentiable function is a continuous, but converse is not true. That is also very important under 3-mark question, my friends. Then started with what? Differentiation. Much of the basic properties, basic things we have done at PUC 1 level, reminding you derivatives of algebraic functions, trigonometric functions, exponential functions have done, e to the power x, and log x to the base e. Those 3 important, my friends. Even e to the power ax is also done, and log x to the base a as a given extension part of it, base e. Yes, my friends, so to prepare there by first principles, e to the power x, a to the power x. You have to prepare even log x to the base e. First principles, my friends, first principles. Remember, after that, examples on uv, u by v, 1 by v, uv, w done. After the completion of that, the great friend who derivatives of composite functions, very important, very important. That concept must be clear to the students. Then only you can proceed happily in further in finding the derivatives in other chapters. Then after that, implicit, then derivatives of inverse trigonometric functions, logarithmic differentiation, and then what? Lastly, successive differentiation, one function with respect to another function, my friends. And this is one set group of what? The chapters, the concepts under what? Differentiation. Composite, implicit, inverse, logarithmic functions, and finally parametric and successive differentiation. Yes, my friends, prepare nicely. This is the main food, I tell you, main food for the friend. Anybody wanted to join engineering, if you are perfect in this area, you will be going to do what? Justice for what? The further study, my friends, further study. Requesting little pressure on the students, my friends, prepare nicely. Then in this differentiation, one more part is left. That part is mean value theorems. Mean value theorems. There are 2 theorems, only statements you have, not proof. Then verifications, examples on mean value theorems, verifications. Yes, my friends, I'll take it in the next video. Yes, my friends, thank you. Yes, see you in the next video.